And a quick word from one of our sponsors. This session is brought to you by GeoComfort. Help your clients live a zero energy and healthy lifestyle with GeoComfort geothermal systems, and featuring a renewed 30% tax credit for these geothermal or ground source heat pump systems. And our main sponsor today is Srinergy. Srinergy has mobile solar generators. These generators, the most powerful solar generator, yet still only weighs 20 pounds, capable of satisfying the demanding need for camp trailers, home appliances, days at a time. The generator is versatile as it is powerful for the ultimate emergency power or camping luxury without the hassle of traditional fuel power generators. This kit comes with all solar panel cables you need to get started, plus a wall charger, connected to the Solar Storm 100 panel, and fully recharge the solar generators within 15 hours of ideal sunlight. And here's some of the recharge times: 2 to 24 hours, wall plug 4 to 8, car 4 to 6. And then here is some of the times that certain devices take to recharge, with getting out of a full charge of a battery 33 hours on an 18 cubic Energy Star certified refrigerator. Srinergy, with years of experience in renewable energy industry, has developed solar microgrid kits as well, with lithium-ion based battery storage for the U.S., Caribbean, Central, and South American markets. Based on highest quality PV panels and hybrid inverter technology that's available to the industry. Their kits provide rugged durability, long life, and reliable performance day in and day out to help keep electricity going for your clients. And also, if you're in Michigan, you can get paid to go solar. If you have anybody located in these particular utility areas that are in colors, reach out to Srinergy today, as they are looking to develop solar sites and pay for that. All right, so this session we're going to be talking about sort of that question that comes up for everybody, whether they're doing a new build or a renovation or have an existing site, and that is, does solar work on my site? And that's a really big question to ask, and you might not know where to start. So we're going to be discussing an easy tool that was developed by NREL to really start that conversation in a less invasive way if you want to start exploring that for yourself or for your clients.
So let's talk for a minute about weather data. As I mentioned before, PVWatts is running hourly simulations, so those monthly and annual totals come from hour-by-hour data. And so these are graphs showing what that data looks like, just so you get a sense of it. So we've got beam and diffuse irradiance. So the beam irradiance is the solar energy that comes to the Earth's surface in a direct line from the sun, and then diffuse irradiance is the solar energy that comes to a point on the Earth's surface from the sky, from everywhere except the disk of the sun. So we need information about both of those quantities to model a PV system. And then we also need wind speed data and temperature data, and that's for the cell, the module cell, or the PV cell calculation. Sorry, the cell temperature calculation. And then this is just an example of 4 days. I took the data from PVWatts and displayed it and graphed it, and so you can just see that it is doing an hour-by-hour simulation. You can see the array output changing and the cell temperature changing. The weather data, again, is from the NSRDB. And it comes from 2 different data sets. The PSMV3 data set is for the Western Hemisphere locations. You can see we start from the northern part of South America and all the way up into Canada and part of Alaska. So we've got 4 kilometer squares covering all of these areas. So any address within this range will return a weather file from the PSMV3 data. And then we have another data set called the SUNY data set for South Asia. And the geographic resolution for the Western Hemisphere is about 4 kilometers. So that I keep mentioning these 4 kilometer squares. That's what they look like on a map. So this is the Denver metro area to kind of get a sense of the scale. And then these squares are a little bigger for the South Asia region. But I mentioned typical meteorological year, TMY data. So this is a method that is used to use 1 year of data to represent a long historical period. So for the PSMV3 data, we have TMY files that represent historical data from 98 to 2014. And for South Asia, it goes from 2000 to 2014. And the way it works is that you have, in this case, we have, 16 years. And so you look through each of the 16 years and you decide which month, which year is the most representative for each month. So we start with January, look through all of the files from 98 to 2014 and say 2006, the January in 2006 was the most representative of the long-term data set. So if you look at a TMY data file, you'll see that the different months have different years, and that's why. And the reason we do this is because this allows us to maintain the relationship between the temperature data, the wind speed data, and the solar resource data. So you don't want to mix temperature from 1 year to solar resource data from another year. Or if you're trying to do some sort of averaging process, you end up with temperature data that doesn't match the solar resource data. So you want the temperature to rise when the solar resource increases, because that's the way it works in real life. So this method allows us to use actual real data so that the correlations between temperature and wind speed and solar resource are all maintained. So that's a quick discussion of TMY. There's more detailed descriptions of the methodology and articles about it on the NREL website. So that's my quick talk on weather data. Any questions about weather data before I move on to other ways to interact with PVWatts?
And I think just to confirm now too, the weather data is pulled from the local airport, correct?
No.
No.
No. So so the weather, here we're zooming into the weather map, and so there's a separate weather file for each of these rectangles. The airport's over here, so there's a weather data over here. So for the older data sets, the TMY2 data sets, that was generally true, but the new data is developed using satellite data. So what they do is, satellites are taking pictures of the surface of the Earth every minute or something, and there are a couple of different methods used for looking at the brightness of the pictures that are taken by the satellite and converting that into solar irradiance. So you take the brightness of the satellite image of this square and you combine it with information about the weather at that same time, and you come up with an estimate of the solar irradiance. So there is a separate weather file for each square here, and it's based on data that was measured for each square from a satellite, and then it's combined with meteorological data from NOAA and other data sources for weather data. So it's actually a pretty complicated process to come up with this data, and it's much higher resolution than just the nearest airport.
Great, thanks.
That was an important point to make, so I'm glad you asked that question. Any others?
Nope.
Okay, so the next section that I'm going to go into is sort of for moving beyond the PVWatts website. There are a number of ways you can interact with the PVWatts model besides the website. And the first that I'll mention here is SAM. And I'm actually, part of my work for NREL is working on the SAM team, so I know a lot about SAM. As far as PVWatts goes, so SAM is a model that models lots of different types of renewable energy systems, and it combines a performance model, so a model of the physical system, with a financial model, which is basically a pro forma cash flow model to calculate the value of the electricity that the renewable energy system generates. So it can model PV systems, and for PV systems, you can choose either the PVWatts model or a more detailed model that that actually models inverters and modules separately. But this is the PVWatts model, and I've coupled it with a residential financial model. So you see, here's our PVWatts inputs. They're exactly the same as the ones we see on the website. And then we have inputs for other, for costs and financial parameters and incentives, electricity rates, electric load. So you need a lot more data to run SAM, but you can get at these questions about electric bill savings based on time of use rates and excess generation and so on. And then SAM generates a lot more results than PVWatts. There's the annual energy, that's the same as PVWatts, but then we've got a bunch of financial metrics like the electricity bill savings, net present value, payback period. So if you're interested in doing a more sophisticated cost or financial analysis with PVWatts, then you might want to check SAM out. SAM is free software. It's a desktop application, so you have to install it on your computer. And it's also developed by NREL. And actually, the underlying code behind PVWatts is part of SAM, is part of the SAM model. There's also a way to interact with PVWatts if you're a web developer and you want to develop a web application that runs PVWatts. Maybe you have a website that does, you want to be able to offer your customers the opportunity to run PVWatts based on the roof of their own home. And so you could write your own little application to generate the inputs for PVWatts and then call the API, as it's called, from your application. Sorry. So for any of you who are web developers out there, that's another free resource provided by NREL, and you can go to this website to get set up for that. There's another way to interact with PVWatts through another API, an application programming interface. So an API is something that a computer programmer uses to write software that interacts with another piece of software, basically. So SAM has something called the Software Development Kit, which allows you to write programs that interact with the SAM API. So this is not for writing web applications, although you could use it for a web application. But like if you're a Python programmer, for example, you can use SAM to generate a Python script that has all of the inputs of your SAM model, and then the Python script would run SAM and generate results. SAM has this built-in code generator that generates Python script or scripts in other computing languages, and it automatically generates all the files that you need to run SAM from Python, including the script itself. And then the last thing I'll say is that PVWatts, as I mentioned, is part of SAM, and SAM is an open source project. So that means that the source code is all available to the public on GitHub.com. And so you can go to GitHub, download all the source code, build your own version of SAM, make modifications, or you can, if you want to make contributions, if there are modifications that you would like NREL to make to PVWatts or to SAM, and you're a computer programmer, you can make those changes yourself and then ask us to evaluate it for inclusion in the NREL versions. You can also use it if you're familiar with programming languages and can read C++. You can actually go and see how how PVWatts works. So this is the code that PVWatts runs when you're using it. So you can actually see how it calculates the cell temperature and the DC output and the AC output. So it's also useful as a resource if you just want to understand more about how PVWatts works. And then I'll close with this list of references. These are papers about PVWatts. The technical manual here, the PVWatts version 5 manual, describes the equations behind the model. And this is for an older version of PVWatts. And then this article or paper describes the assumptions. It's kind of a useful reference if you want a little guidance on how to choose values for your PVWatts runs. And then this is some guidance on using PVWatts with microinverters and DC power optimizers. It basically gives you advice on how to choose the losses for these types of systems. So that's all I had prepared, and but I'm happy to entertain any more questions.
All right, thanks, Paul. I do see a couple questions, but let me get to one thing here real quick before we get to those. Thanks, all of you, for joining us here. And big thanks to all of our board of directors, our volunteers, and our big sponsors, Srinergy, T-Stud, most efficient wall stud assembly, and Mitsubishi Electric, all-electric net zero home HVAC solutions. Thanks to them and all of our sponsors and all of you for allowing us to do what we do. So real quick, there was a very specific question. And I don't know if it's going to require you to share your screen or not, but it says, example, if building roof orients southwest 225 degrees, and I set the AZIMUTH at 180, does PVWatts automatically model with reduced output since it won't fill the roof perfectly due to offset due south orientation on a southwest-oriented roof? But hopefully you can see that.
Okay, yes, I can see that. And so if you set the azimuth in PVWatts to 180 degrees, it doesn't know anything about your building roof orientation, so it's just going to model the array as if it's oriented south. It sounds, I'm not exactly sure I understand the scenario. If it sounds like maybe the size of the array is going to be impacted. If you're orienting the modules at 180 degrees, so you're not going to be able to fill the entire roof because the modules aren't lying flat on the roof, then you would have to account for that by reducing the nameplate capacity input compared to what it would be if the modules were lying flat on the roof. So I guess the answer is that PVWatts isn't going to automatically calculate that for you. So you'd have to figure out what the module area is going to be based on the way you're orienting the modules, and then calculate the nameplate capacity from that, and then use that as input into PVWatts.
And I think this is kind of going back to some stuff you covered, but we can go over it again. Is there a way to model a seasonally adjustable tilt ground-mounted array, or would you run the model for each season and just look at that output for that season?
Yeah, so in PVWatts, you can't change the tilt seasonally. So what you could do is, yeah, just run it at your winter tilt value, and then look at the outputs during the winter months, and then go back and change the tilt angle to the summer tilt values, and then look at the outputs for the summer months. You can do a seasonally adjusted tilt. Let me just check. I know that the detailed PV model in SAM does that. I'm not sure if we implemented that for PVWatts. I'm just checking here. Yeah, no. So the tilt is not seasonally adjustable for PVWatts.
Is that on the docket to update?
I don't think for PVWatts it is. It's something that we've implemented for the detailed photovoltaic model in SAM. So I mean, PVWatts is designed to be simple. So we generally try to avoid adding more features because it might work. There might be some small number of people who want to do seasonal tilt adjustments, but then it creates more complexity for the rest of the folks who don't even know what that means. So we're constantly trying to strike a balance between maintaining the simplicity of the model and making sure that it can do what people want it to.
A specific question, or well, two questions on SAM. And maybe one's very detailed, so you can just kind of discuss it at a high level. But how does SAM deal with small, medium, and large multifamily developments, and can it be used outside the USA?
So I'll take the second question first because it's easy. Yes, both SAM and PVWatts can be used to model systems outside of the U.S. The main challenge there is making sure that you can find weather data. But now with the new NSRDB, we've got a lot of the world covered with the NSRDB, and there's another weather data set called PVGIS that covers the rest of the world. So SAM can interact with both of those data sets. As far as modeling multi-family developments, SAM's got some tools for sort of combining multiple systems into one project. I'll sort of leave it at that for now because I don't want to go into too much detail there. But there are some ways to model sort of large complex systems in SAM.
Do you have any advice for teams who are what we call trying to determine the current solar income of a site for a new build, so they can kind of work backwards and say, okay, here's all we can really get out of solar, and this is what we know we need to hit our energy demand loads on. Any suggestions on using it for something like that? Somebody actually did that, and that's how I was kind of inspired by the fact that you maybe could do that.
Yeah, no, I think that kind of analysis is exactly what a model like SAM is good for, and PVWatts to some extent. I mean, you can sort of try out different possible future scenarios and see how they compare. For that particular situation, you need some load data, and you're going to look at different load scenarios. And we've got some tools in SAM that allow you to download some synthetic load data for various building types in different climates. So you could kind of run your model for an efficient, more efficient home, or a home that uses less electricity compared to one that uses more, but that follows the seasonal pattern. So you'd account for high summer air conditioning loads in the Southwest, for example. And then you could look at different electric rate structures, sort of considering different whether the homeowner just gets a flat rate or whether they get a really complicated rate structure with time of use rates and tiered rates and demand charges. That's usually a big one. So all of that you can most certainly model and account for in SAM.
Great. Paul, those are all the questions we have, so I certainly appreciate your time taking us through this here. And just real quick, if people have more questions or want to learn more or access the tool, where can they go?
Well, just let's see. I'll take you back to the PVWatts website. Is pvwatts.nrel.gov, and you can use the contact, the feedback button here to email us. That's the best way to reach us. And I monitor that email address, so if you send an email there, I will get it.
All right. Well, Paul, I appreciate your time. Thanks to NREL for having you out, and have a great rest of the week, everybody. Take care.
All right. Thank you.